All right, welcome back to another video. So it's been a few days away. It looks like my audio's looking good. Last video I made was 3 days ago. So, so it's now Friday. I am running a little bit behind the schedule.
All right, welcome back. So we are
Um,
still
I'm at danger of falling behind. But typically I do a uh, an hour video. That's kind of where I have trouble continuing on. Um, and that's not good enough, right? Like a 40-hour work week is 40 hours. Productive, you should be able to be productive for about 6 hours of those days. I mean, 1 hour out of a 5 hours a week, that's not enough. So I have found that if I simply take a 5 to 15 minute break, or even longer, a half an hour break, I can easily make a 2 hour video. Um, like, and if I take another break, I can easily make a 3 hour video. So there's really no reason these videos should be less than 3 hours if I'm working on a course like this. So if I make this video 3 hours, I will be making up the difference for the videos I didn't make the last 3 days. And then if I continue to make videos for 3 hours a day, which there's really no reason not to do. I'm in between jobs. I'm really interested in reshaping my career to be at the forefront of this AI evolution. So I'm not revolution, so I'm not left behind by it. And I just want to be like a guru at open source AI for its own sake, right? Because like these companies, OpenAI and stuff, are going to be trying to monopolize this technology and use it in ways that only benefit themselves and their customers. So like I want to be a part of the people with the know-how to um, drive their own Ferrari rather than having to take the city bus. So like I want to use AI for my own purposes. I want to own the AI that I use, and I want to be able to um, uh, help others use AI in the way they want to use it rather than in the way a company forces them to use it. All right, so that brings me to Unit 2.2. I should be able to get through this whole unit pretty by the next time the next one is released. Let's take a look at the schedule quick. So Unit 2.3 is going to be released March 11th. So every Tuesday they get released. So I have plenty of time. All right, and unfortunately I do need a quick break. I'll be right back. All right, I'm back. I will need to take another break in a few minutes, though. So this is Introduction to Llama Index. So now we're moving away from small agents, which is the Hugging Face agents framework. You don't have to use a framework when you build agents, but if you do, you can do extra things with the framework. With small agents, you can build rapid prototypes and host them on Hugging Face. So we can see I've got my own agent uh, product that I'm hosting on public space here. It's a planning agent. I'm hoping I could sell something like this to like a cleaning company where like they can say like, oh, I've got a job here. Somebody hired me to do 60 minutes. So I'm going to spend the first 5 minutes just describing everything that the client needs me to do. I'm going to provide an estimate how long it'll take. Or you can even get this directly from the client, right? So like clean, like you can just as part of you can make the client fill out a form, right? And then generate the cleaning plan and then assign someone to the plan and send them out. So you could use this as a way to like manage what people in your cleaning company do. You can use it as a way to kind of distribute the resources of your cleaning company. If a client only needs one thing cleaned, the agent can manage your inventory better. Okay, well, you don't need to bring this or that cleaner, um, and you can help you organize concurrent cleaning tasks with a just-in-time inventory rather than having to keep a massive inventory of unused things. You can have a just-in-time inventory, which has been kind of a revolutionary thing in uh, that businesses have done. But I got to get the agent working. But that's the advantage. Yeah. So here's the agent response. I got to get that to display on the page, which I could probably do in just one more hour of work. But anyways, so that's your advantage with small agents. Rapid, shareable prototyping. That is part of the best online space for AI. So now we're going to learn about Llama Index. Welcome to this module where you'll learn how to build LLM-powered agents using the Llama Index toolkit. Llama Index is a complete toolkit for creating LLM-powered agents over your data using indexes and workflows. For this course, we'll focus on three main parts that help build agents in Llama Index: components, agents, and tools, and workflows. So, all right. Let's look at these parts of Llama Index and how they help with agents. Components are the basic building blocks you use in Llama Index. These include things like prompts, models, and databases. Components often help connect Llama Index with other tools and libraries. Tools. Tools are components that provide specific capabilities like searching, calculating, or accessing external services. They are the building blocks that enable agents to perform tasks. Agents. Agents are autonomous components that can use tools and make decisions. They coordinate tool usage to accomplish complex goals. Workflows are step-by-step processes that process logic together. Workflows or agentic workflows are a way to structure agentic behavior without the explicit use of agents. What makes Llama Index special? While Llama Index does some things similar to other frameworks like small agents, it has some key benefits. Clear system workflow. Workflows help break down how agents should make decisions step by step using an event-driven and async-first syntax. This helps you clearly compose and organize your logic. Advanced document parsing with Llama Parse. Llama Parse was made specifically for Llama Index, so the integration is seamless, although it is a paid feature. Many ready-to-use components. Llama Index has been around for a while, so it works with a lot of other frameworks. This means it has many tested and reliable components like LLMs, retrievers, indexes, and more. Llama Hub is a registry of hundreds of these components, agents, and tools that you use within Llama Index. All these concepts are required in different scenarios to create useful agents. In the following sections, we will go over each of these concepts in detail. After mastering the concepts, we will use our learnings to create an applied use case with Alfred the agent. Getting our hands on Llama Index is exciting, right? So what are we waiting for? Let's start with finding and installing the integrations we need using Llama Hub. All right, and I'll take a break. I'll be right back. All right, I'm back. So, introduction to the Llama Hub. Llama Hub is a registry of hundreds of integrations, agents, and tools that you can use within Llama Index. So, Llama Hub is like Q's lab in the basements of M16. We can use it to find the most wonderful gadgets for agents. Oh, cool. So, you don't have to write your own tools. You can use tools that's already been written. So it's basically the equivalent of, because Hugging Space has this as well. You can go to Spaces and you can use any of these as tools for your agent. So um, So open and advanced large scale video generate. Yeah, so you can give your agent the ability to generate videos like Sora using this. Wow, this is cool. Let's try it. So let's give it a uh, let's describe the video. So oh, what would be a good description? Let's just sort of mailman delivering the mail. Because now we can see, like, if it's really off, we can very easily tell whether or not it generated a mailman delivering the mail. Okay, so it's going to take a long time because they're giving this out for free, so you have to contend with everyone else who is using it. Uh, Community grant, that's interesting. This space needs a community grant to run on the shows. Users should be allowed to use it, but models is probably not maybe out of China. So good work, guys. Okay, how do I can I apply for a community grant? Whose space is this talking about? Oh, this is the okay. So I see, I see. So, right now we're in a space, right? So like these tabs all apply to the space. I thought these were messages directed towards me, but those would be my notifications. It confused me too because the number was the same. We can see. So these are messages directed towards the space. So this is somebody saying that they don't want to wait for 600 uh, minutes, was it? I don't know how long to use this. All right. So we will be using various integrations in this course. So let's first look at the Llama Hub and how it can help us. Let's see how to find and install the dependencies for the components we need. Installation. Llama Index installation instructions are available as a well-structured overview on Llama Hub. This might be a bit overwhelming at first, but most of the installation commands generally follow an easy-to-remember format. So pip install llama index dash component type dash framework name. So if we go up here, um, yeah, I'm not sure what it would be for that. So let's try to install the dependencies for an LLM component using the Hugging Face Inference API integration. So pip install llama index LLMs Hugging Face API. So isn't this cool? They give you these special tools to interact with other frameworks. So if you're not on Hugging Face, you've got to do all this. You have to write this inference API yourself. All right, so usage. Once installed, we can see the usage patterns. You'll notice that the import paths follow the install command. Underneath, we can see an example of the usage of the Hugging Face Inference API for an LLM component. So from llama underscore index dot LLMs dot Hugging Face underscore API, import Hugging Face Inference API. So there we go. So we remember this from, if we go to my project, we'll see the same code. So let me duplicate that tab, go to one of my projects. We'll go to my main project that I care about, this cleaning agent project that I haven't worked on in nearly a week. And then we'll go to the files, and then let's see. So let's think about where this would be, right? It would be in under app, I think. Hugging Face Inference API. Interesting. Okay, so this code looks very similar to the code here that was used with HF API model. So I'm not sure what the difference is between Hugging Face Inference API and HF API model. So let me finish reading this, and then we'll have a discussion with ChatGPT. Wonderful. We now know how to find, install, and use integrations for the components we need. Let's dive deeper into the components and see how we can use them to build our own agents. All right, so let's have a discussion with ChatGPT. Hey, I need your help understanding something. There's this website called Hugging Face, and they have various Python tools you can use. One of them is SMOLAGENTS, and another library they have is Hugging Face underscore API. So you would so when you're ready, I'll give you a code snippet that uses each of these libraries, and I'd like you to tell me the difference between the libraries, please. Are you ready now? Okay, so here's a clear comparison between the two libraries you're using in their code snippets. So the one here shown in this example, so wonderful. Now we know how to find, install, and use integrations for the components we need. Let's dive deeper into the components and see how we can use them to build our own agents. So this is a simple interface provided by Llama Index to connect and directly communicate with the Hugging Faces hosted inference API endpoints. It's designed primarily for straightforward tasks such as completing prompts or generating text. What it does in your code, you initialize it with the model you want to use. You have to give it an API token and model settings like temperature and token limits. You use LLM.complete to send prompts directly to a hosted Hugging Face model and receive textual completions. So typical use case, quick and direct inference requests to Hugging Face models without needing complex agent behaviors or multiple tools. Okay, so now let's see what the difference is between this. So this is part of, okay, so it's basically the same. Okay, so long story short, would you basically say that these are the exact same things, except for one is in the context of SMOLAGENTS and the other is in the context of Llama Index? Not exactly. Okay, so they're similar in that they both provide a Python Hugging Face to Hugging Face's inference endpoints, but they're not identical tools, just placed in different contexts. This one provides a interface, okay, within the Llama Index ecosystem. Okay. Well, is it as simple as saying that one is for the Llama Index ecosystem and the other one is for the SMOLAGENTS ecosystem? Or is it more complicated than that? Okay. Yeah, so that's the difference. Is like this inference API points to things relevant to Llama, whereas in the example I saw, this inference API here. Oops, if I can click correctly. Yeah, this inference API down here points to things associated with small agents. So you still need an inference API. You still need an API model. These could be the same, but what? Well, I'm curious about that. So tell me more about the. Okay, well, tell me more about the coding decisions, the naming decisions that were at play here. Like, why would you not just call both of these the same name? Like how come when it's from SMOLAGENTS, you would import HFAPI MODEL, but when it's from llama underscore index dot LLMs, there you have dot hugging face underscore API rather than dot HFAPI model. Um, or like why don't you just have it be like hugging face underscore API import HF API model? So do you know what I mean? Like why is there a difference in naming like that? Okay, so each ecosystem tends to follow naming patterns consistent within its own framework. Okay, because this is part of the Llama Index ecosystem, um, notice how Llama Index is separated by an underscore. So they decided to mimic that in their naming there. This is a different casing choice, which they're using for their own framework, but that Llama Index didn't use. They didn't get the choice to choose that for Llama Index, so they simply mimic it. This module lets you access Hugging Face models via their official API. Okay, why this name? Modular agents, model or tool. Okay, all right. And they do different things. The Llama Index one directly exposes Hugging Face's inference API. So underscore API. Um, so it's a low level explicit and direct library. And this is a higher level agent oriented library. Yeah, so not the same name because they align with the internal naming convention. And this is especially relevant for this because this is an add-on to Llama Index, so it follows their naming choices. It also reflects the level of abstraction. This is a low-level unabstracted one, so we're importing a more. We can see that the what we import must be a higher level of abstraction, so we have a different naming uh, choice to reflect that. And then the actual names like small agents you can abbreviate HF for Hugging Face because it is a Hugging Face library already. Llama Index, you probably do need to spell it out in full because people won't know because Hugging Face is not contained within its own ecosystem. It's a part of another ecosystem, so you have to spell it out in full. This is a Hugging Face library. So okay, makes sense. All right. So I'll be back in just a minute. All right, I'm back. I should be able to lock in for a bit here. So next section is what are components in Llama Index? Remember Alfred, our helpful butler agent from Unit 1? To assist us effectively, Alfred needs to understand our requests and prepare, find and use relevant information to help complete tasks. This is where Llama Index's components come in. While Llama Index has many components, we'll focus specifically on the query engine component. Why? Because it can be used as a retrieval augmented generation RAG tool for an agent. So what is RAG? LLMs are trained on enormous bodies of data to learn general knowledge. However, they may not be trained on relevant and up-to-date data. RAG solves this problem by finding and retrieving
relevant information from your data and giving that to the LLM. So this is a retrieval augmented generation, a infographic. So here's Alfred, our agent. Reg helps me make informed decisions on top of factual data you care about. So here's the data we care about. We have a database, a document, and an API. The database is structured data. The document is unstructured, and the API is programmatic data. So they all go into an index, and what the user does is performs a query to that index. Then the prompt plus the query plus the relevant data go into the LLM, and the LLM responds. So if you have reg, you can use up-to-date information. You've probably all seen that message. Oh, sorry, my cutoff date. I don't have that information. Well, if it has reg, it can go and look up the latest information. Now think about how Alfred works. You ask Alfred to help plan a dinner party. Alfred needs to check your calendar, dietary preferences, and past successful menus. The query engine helps Alfred find this information and use it to plan the dinner party. This makes the query engine a key component for building agentic RAG workflows in Llama Index. Just as Alfred needs to search through your household information to be helpful, any agent needs a way to find and understand relevant data. The query engine provides exactly this capability. Now let's dive a bit deeper into the components and see how you can combine components to create a RAG pipeline. Creating a RAG pipeline using components. You can follow this code in this notebook that you can run on Google Colab. So here we've got a notebook to work through, which can take quite a bit of time. Let's go through the basics of the notebook. So we're going to have to log into the Hugging Face hub. So let's install all the dependencies and then log in. All right, but anyway, moving on. There are 5 stages within RAG, which in turn will be a part of most larger applications you build. These are number 1, loading. This refers to getting your data from where it lives, whether it's text files, PDFs, another website, a database, or an API, into your workflow. Llama Hub provides hundreds of integrations to choose from. Number 2, indexing. This means creating a data structure that allows for querying the data. For LLMs, this nearly always means creating vector embeddings, which are numerical representations of the meaning of the data. Indexing can also refer to numerous other metadata strategies to make it easy to accurately find contextually relevant data based on properties. Number 3, storing. Once your data is indexed, you will want to store your index as other metadata to avoid having to re-index it. Number 4, querying. For any given indexing strategy, there are many ways you can utilize LLMs and Llama Index data structures to query, including subqueries, multi-step queries, and hybrid strategies. And number 5, evaluation. A critical step in any flow is checking how effective it is relative to other strategies or when you make changes. Evaluation provides objective measures of how accurate, faithful, and fast your responses to queries are. Next, let's see how we can reproduce these stages using components. Loading and embedding documents. As mentioned before, Llama Index can work on top of your own data. However, before accessing data or assessing data, um, we need to load it. So before assessing the data, rather than accessing the data, we need to load it. There are 3 main ways to load data into Llama Index. Simple Directory Reader, a built-in loader for various file types from a local directory. Llama Parse. Llama Parse, Llama's Index's official tool for PDF parsing, available as a managed API. Llama Hub, a registry of hundreds of data loading libraries to ingest data from any source. Get familiar with Llama Hub loaders and Llama Parser for more complex data sources. The simplest way to load data is with Simple Directory Reader. This versatile component can load various file types from a folder and convert them into document objects that Llama Index can work with. Let's see how we can use Simple Directory Reader to load data from a folder. So from llamaindex.core, so this will be part of the notebook. So let's come back to that after we've prepared the notebook. So now I need to add the token. I'll do that off camera. All right, I'm back. I have added the token. Let me clear out my clipboard in case I accidentally pasted somewhere. But we see the green check mark there, so this has been run. So next we're going to create a query engine for augmented generation, setting up the persona database. So we'll be using personas from this Hugging Face space, right? Well, it's a Hugging Face data set, not a Hugging Face space. So you can go to datasets here and explore all the datasets they have on Hugging Face. But we're going to use this one, find personas. Uh, yeah, grant access. Okay, there we go. So I have under secrets here, I have a notebook access token named this, which is what this code calls for. Um, needed access to. I'm not sure where it needed access to that. Probably for this load datasets needed it. Yeah, I'm not sure which line of code called for that. I think it was probably this one. But we can see I do have this defined as a variable. I just didn't have it flipped on. So it asks me if I want to flip it on, and that grant access flips this on, and now the notebook can use it. All right, so awesome. Now we have a local directory with all the personas that will be attending the party. We can load an index. So loading and embedding persona documents. We will use the simple directory reader to load the persona descriptions from the data directory. This will return a list of document objects. All right, so let's get a list of document objects. We'll see how long that list is. So we got 5,000 document objects. Now that we have a list of document objects, we can use the ingestion pipeline to create nodes from the documents and prepare them for the query engine. We will use the sentence splitter to split the documents into smaller chunks and the Hugging Face inference API embedding to embed the chunks. All right, so I noticed that this was in yellow here. So yeah, immediately we do have an error here. So there's no module named llamaindex.embeddings.huggingface API. So perhaps we can get this somehow. So let's take a look at our import statement for llama index. So here it is for llama index. Um, Now here it is there as well, llama index. So I think it was, yeah, so yeah, we can see all you got to do is pip install llama index LLM token face API. So we have that there, but for some reason, I don't know, maybe it failed or something. It looks like I don't see a error message about that failing. So that should have been that should have been it. Let's create a new cell um, below, and let's just specifically feed it this. All right, and yeah, it's so it says that it's already satisfied. So I'm surprised that we're not able to. Oh, you know what? I think I see the problem here. This doesn't look right. Hugging Face Inference API embedding, is that? I don't. I thought it was Hugging Face Inference API. I didn't think that it was the embedding there. But we let's make another cell and play around with this because this is installed, right? So like we have that. So let's do oh, the other thing we might be able to do yeah, so let's just play around with the code. So now we can see some things autocomplete. And we do see that this line auto completed. So let's okay. So that's interesting that it auto completes, but yet it doesn't exist. Okay, so we can see here when I do a dot, we've all we got is OpenAI as a suggestion there. Here we do have, but I thought it would be LLMs dot. Yeah, so we can see there's a difference between the suggestion and between what pops up when that I can tab out. Yeah, so now I can see that it's there. So this works. This line works. Yeah, so we got a green check mark on that line. Um, okay, so we got an error here. So you can't use it like that. You basically have to use, yeah, the ingestion pipeline doesn't work that way. Well, anyway, let's keep reading this and then come back to the notebook. So after loading our documents, we need to break them into smaller pieces called node objects. A node is just a chunk of text from the original document that's easier for the AI to work with, while it still has references to the original document object. The ingestion pipeline helps us create these nodes through two key transformations. Number one, sentence splitter breaks down documents into manageable chunks by splitting them at natural sentence boundaries. Number two, Hugging Face Inference API embedding converts each chunk into numerical embeddings, vector representations that capture the semantic meaning in a way AI can process efficiently. This helps us organize our documents in a way that's more useful for searching and analysis. Okay, so now we do have this line here. Yeah, so now we're reading about where about this code. So maybe there's an error in the code in like this statement or something. So let's the first thing I'm going to try is to just paste this in over what's in here and then try to run it. Okay, so we got the same error. So there's definitely not a module named that. Okay, well let's go to the let's talk to ChatGPT about this. And I've got a few questions for ChatGPT. So let's start with just a question off the top of my head that I'm confused about when it comes to RAG. And we can use let's use voice mode for this question. Hey, are you familiar with retrieval augmented generation?
Yes, I'm familiar with it. Retrieval Augmented Generation, or RAG, is a technique that combines retrieval-based and generative models. It retrieves relevant information from a large corpus to provide context for generating more accurate and informative responses. Are you exploring this approach for a project?
Well, I've got a confusion about it. So like so I know so retrieval augmented generation, right? Like it can reach out to like a database, bring in information, but I don't understand like how it can meaningfully use that information, right? Because like the training process for an AI is like a potentially like $1 billion process that requires a massive data center and using a 3 Mile island repurposed up and running again, nuclear power. So, like, how can it just like magically like utilize this information it called out to without having to go through another sort of like training process?
That's a great question. RAG combines pre-trained generative models with a retrieval mechanism. Essentially, the model itself is trained on large data sets, but during inference, it can pull in up-to-date or specific information from external sources. This way, it doesn't need to be retrained entirely to access new data. The retrieval component dynamically fetches relevant information, while the generative model uses this information to generate contextually rich responses. It's more about enhancing the model's responses with retrieved data rather than retraining it each time. Does that help clarify?
Yeah, I think so. So would you say like the one word answer to my question would be inference?
Yes, inference would be a fitting one-word answer.
Cool. Well, thank you. You really helped me out.
You're very welcome. I'm glad I could help. If you have any more questions, just let me know.
Wow. Okay. So here we go. What is AI inference? So inference is the process that a trained machine learning model uses to draw conclusions from brand new data. Fascinating. Okay. So inference versus training. Training is the first phase for an AI model. Training may involve a process of trial and error, or a process of showing the model examples of the desired inputs and outputs, or both. Inference is the process that follows AI training. The better trained a model is, the more fine-tuned it is, the better its inferences will be. However, they are never guaranteed to be perfect. So I think if you have a model that is intended to do a lot of RAG, one of the things you want that model to be able to be very good at is inference. So if you're deploying models, we learned just how important evaluation pipelines are. Um, you definitely want to evaluate the model's ability to do inference. That's absolutely key. Otherwise, if you're deploying that model for RAG, it's not going to be able to do that very well if it's not very good at inference. So let's take a look quick at and this is kind of an aside, and this is related to something else I'm doing off camera, but um, it's really important to, as we read in the other series, evaluation pipeline is basically the first thing you should be able to do if you want to be an AI professional. You have to learn how to evaluate the models. Um, that should be the first thing that you can do. So luckily, Hugging Face has the Evaluate library, which makes things a lot easier. But what I want to do just briefly is see if I can evaluate inference, because I feel like you want to evaluate that. You have to evaluate. Um, Here we go. So types of evaluations. So we can evaluate metrics. We can evaluate comparisons, measurements. But I want to know if we can evaluate inference. Uh, so let me go to ChatGPT again, and we'll have a more of a text-based conversation. So I'll feed it. Let's actually use operator. Yeah, operator's really awesome. So tell me if it's possible to use this library. So tell me if it. Oop, and my keyboard stopped working. So tell me if it is possible to evaluate inference using this Python library. All right, so operator's gonna look through this and come to a conclusion. Yeah, operator is really cool. I like operator. And this is based. The other thing to know about operator is I have the pro subscription, but this is what basically what you're gonna get for $20,000 a month if you're an oligarch. Um, you're going to be able to have a box like this that can access anything on the internet without getting shut down. And also the pipe you get, the internet connection from this box will be massive. And not only that, the model behind all these are going to be massive. So that could be worth 20,000 a month if you have a internet a version of operator that it has not only doesn't have any constraints but is optimized to pay for itself. But $24,000 a year, like, man, does it have to be good. All right, so the evaluate library documentation confirms that it can access inference-related metrics like latency and samples per second, crucial for evaluating inference performance. However, there isn't a dedicated section explicitly focused on inference evaluation. Okay, tell me more about inference related metrics. Related metrics provide me with the links uh, in the documentation that are relevant to it. Ah, look at this. So we've got inference endpoints, dedicated inference endpoints. So, but I mean, this is kind of neither here nor there. It's not really related to the documentation, so I'm kind of tempted to move on from this a little bit. So, access metrics via API. This page explains how to access inference metrics. Customize Prometheus queries. All right, this seems pretty important. And then text generation inference metrics. Metrics for monitoring inference performance, including batch size, decode duration, and forward duration. All right. Well, whatever. But moving on. All right, so really what I need is why does this code not run here? So let's figure that out. Ah, I see. So in recent versions of Llama Index, the embedding integration with the APIs has moved. So this statement is different. It's going to be yeah. So this here is renamed. So this should fix the issue. Um, well, that's not. No, it didn't get that right. Not true. All right, so this seems to be making a dent. It looks like I don't already have this library, so it's installing it. So moving on, storing and indexing elements. After creating our node objects, we need to index them to make them searchable. But before we can do that, we need a place to store our data. Since we are using an ingestion pipeline, we can directly attach a vector store to the pipeline to populate it. In this case, we will use Chroma to store our documents. So, yep. So this is how you install Chroma, as introduced in the section on Llama Hub. We can install the Chroma DB vector store with the following command. And then here's the next part of the cell. So an overview of the different vector stores can be found in the documentation. This is where vector embeddings come in. By embedding both the query and nodes in the same vector space, we can find relevant matches. The vector store index handles this for us using the same embedding model we used during ingestion to ensure consistency. Let's see how to create this index from our vector store and embeddings. So, okay. All information is automatically persisted within the Chroma vector store object and passed directory path. Great, now that we can save and load our index easily, let's explore how to query it in different ways. And there we go, we've got that installed, so hopefully this cell now works and we can get our nodes. Aha, so we've got our nodes now. Um, I believe. Yeah, so now we're able to use this line. It doesn't just automatically fail out now. So it looks like it's changing the yeah, so it is payment required. Wah wah. Okay, gotta pay. Well, I'm not gonna pay. I'm not gonna pay. Dang it. Pay, pay, pay. That's what life is all about. You have to pay. You have to pay a lot of the times. If you don't, there's a fee on your payment. So if you don't pay the fee, your payment's not gonna go through. Like for example, a credit card. There's a credit card fee. You have to pay to pay, and sometimes you even have to pay to pay to pay. You have to buy a payment app or the credit card itself. Uh, oh, right, right, deprecated class. Oh, but now it worked though. Oh, but I put in the wrong code. I should have put it in this code. Okay, and now I've got the wrong line here. Uh, oh, now we got this payment required again. So it looks like you gotta pay if you're gonna use this feature, which is surprising. I thought they had these set up so that you could go through this without paying. Well, anyways, I guess I thought wrong. So let's try to get through the rest of it. The fact that I'm not paying for whatever is so as you can see, we have created a list of node objects, which are just chunks of text from the original documents. Let's explore how we can add these nodes to a vector store. So storing and querying documents. Since we are using an ingestion pipeline, we can directly attach the vector store to the pipeline to populate it. In this case, we will use Chroma to store our documents. Let's run the pipeline again with the vector store attached. The ingestion pipeline caches the operations, so this should be fast. So, ingestion pipeline, gotta pay for that too. We can create a vector store index from the vector store and use it to query the documents by passing the vector store and embedding the model to the from vector store method. Well, they can, I can't because I didn't pay. We don't need to worry about persisting the index to disk as it is automatically saved within the Chroma vector store object and passed and the past directory path. So querying the index. Now that we have our index, we can use it to query the documents. Let's create a query engine from the index and use it to query the documents using a specific response model. All right, index is not defined. Evaluation and observability. It looks like the text is quite a bit different from one to the other. Um, but I think this is very nearly done. So let's just close this out and then go back and read the other one. So evaluation and observability. Llama Index provides built-in evaluation tools to assess response quality. These evaluators leverage LLMs to analyze responses across different dimensions. We can now check if the query is faithful to the original persona. So there we go. Name response is not defined. If one of these LLM-based evaluators does not give enough context, we can check the response using the Arise Phoenix tool after creating an account at Llama Trace and generating an API key. All right, now we can query the index and see the response in the Arise Phoenix tool. We can then go to Llama Trace and explore the process and response. All right, so that's it for that. Let's take a brief look into the pricing for so we can see right there we've got pricing. So you know what? I could cancel my subscription um to ChatGPT, and I could subscribe to Hugging Face instead, to the Enterprise Hub. And Then I could get probably access to that API. Then now this starts at $20 a month, so it could be more than that. Yeah, I think this is what I'd probably have to get to. Yeah, I'd have to deploy models on, yeah, dedicated endpoints. Yeah. See, the thing is, like, I want to do this myself. There's a guide, FUTO, by Lewis Rossman that I could pull up if my keyboard was working, but apparently it's not. Um, yeah, so this guide to the self-managed life. I'm very near to making this work. I have my VPN set up. Everything. I have everything set up um, so that this is very nearly working all the way through. It takes a while for the page to load. There's just a lot on this one page. It takes 13 hours just to give the presentation. To actually set it up, it takes much longer than that. So this is the step I'm on right now. I have a ad blocker that I'm playing with. So at some point over this, the point where we have a some parts of my system. The point where we have a uh, hmm. Yeah, I think at the point where we're replacing Google Drive, Photos, Docs, Sheets, and Keep with our own machines, storage machines, where we're setting up the software. I think this is probably the point where we can get, especially the point where we have uh, Ubuntu server up and running for virtual machine management. That's the point where I could just spin up a machine with a VM with access to powerful GPUs, and instead of opening these in Google Colab, run them locally on my GPUs, and I can invest in some a GPU with a lot of juice. Right now, the most powerful thing I have is a RTX 2060. Um, but we can see if we go to this database, want want 6, not very good. The so it's in fact it's 5 times less powerful than the current offering, which has 32. So this would be quite an upgrade for me, especially for these kind of smaller tutorial things. So that would be a limited time. Uh, that would be at a price of $2,000, which is kind of a lot, but depending on what you're doing, perhaps not. The other thing to point out is the prior reigning champ, which has 24, which is a lot better than 6, is probably going to fall very rapidly in price now that the new one's out. So, yeah, this is already down to 1500. And then the thing is, why do I need something that is 500 times more powerful, right? I can take my pick, and so I've got this 2060. Um, so here we go. This is 3 times more powerful. It's got 24 rather than 6, so that's 4 times what I got. And sure, I could pay $2,000 for the other one, but look at this, refurbished here for less than 700. So you can make smart decisions for sure. You don't have to just go and blow all your money. Yeah, this is probably what I would do if I were to upgrade is do that. It would be nice to get some so that's a 300% increase. Um yeah, it looks like a 3080 would even be double my current, yeah, so this RTX 30 is double it. So yeah, and that take me from 6 to 10, which would be good. I mean, it's not super good, but these are under 700. These you can, it looks like you can get this for under 400. All right. So yeah, if I want to put some money down to really enhance my home rig, it looks like a really good option for me would be this 3090, um, so that I have 4 times the memory I was dealing with before. And if I get lucky, I could even get it. Oh, look at this. Uh, this is a 4060 for um, 334. It's so annoying that like you put in like I put in something very specific, and I'm not getting results back that match what I put in. Uh, well, anyway, moving on. So querying a vector store index with prompts and LLMs. Before we can query our index, we need to convert it to a query interface. The most common conversion options are as retriever for basic document removal, returning a list of node with score objects with similarity scores. As query engine is another way to convert the index into a query interface. This is for single question answer interactions, returning a written response. This is as chat engine for conversational instructions that maintain memory across multiple messages, returning a written response using chat history and index context. We'll focus on the query engine since it is more common for agent-like instructions. We'll also pass in an LLM to the query engine to use for the response. All right, so response processing. Under the hood, the query engine doesn't only use the LLM to answer the question, but also uses a response synthesizer as a strategy to process the response. Once again, this is fully customizable, but there are three main strategies that work well out of the box. Refine. Create and refine an answer by sequentially going through each retrieved text chunk. This makes a separate LLM call per node/retrieved chunk. Compact, default, similar to refining, but concatenating the chunks beforehand, resulting in fewer LLM calls. Tree summarize. Create a detailed answer by going through each retrieved text chunk and creating a tree structure of the answer. Take fine-grained control of your query workflows with the low-level composition AI, or API, not AI, the API. This API lets you customize and fine-tune every step of the query process to match your exact needs, which also pairs great with workflows. The language model won't always perform in predictable ways, so we can't be sure that the answer we get is always correct. We can deal with this by evaluating the quality of the answer. Evaluation and observability. Llama Index provides built-in evaluation tools to assess response quality. These evaluators leverage LLMs to analyze responses across different dimensions. Let's look at the three main evaluators available. Faithfulness evaluator evaluates the faithfulness of the answer by checking if the answer is supported by the context. Answer relevancy evaluator uh, uh, evaluate the relevance of the answer by checking if the answer is relevant to the question. Correctness evaluator. Evaluate the correctness of the answer by checking if the answer is correct. So from llamaindex.core.evaluation, so they have their own evaluation library in Llama Index. They have and you can import any one of these. In this case, they have chosen to import the faithfulness evaluator. Even without direct evaluation, we can gain insights into how our system is working through observability. This is especially useful when we are building more complex workflows and want to understand how each component is performing. So install Llama Trace. As introduced in the section on the Llama Hub, we can install Llama Trace callback from Erizi Phoenix with the following command. Okay. Additionally, we need to set the Phoenix API key environment variable to our Llama Trace API key. We can get this by creating an account at Llama Trace, generating an API key in your account settings, using the API key in the code below to enable tracing. Want to learn more about components and how to use them? Continue your journey with the components guides or the guide on RAG. We have seen how to use components to create a query engine. Now let's see how we can use the query engine as a tool for an agent. All right, so this might be, let's see how long this is. This is pretty short. I feel like I should just finish all of this up today and then work more on my project if that's possible. At the very least, we should finish everything up until quick quiz 1 and then divide it and then start back there in another video. So let's take a look at the clock. Okay, I'm over the hour mark. I'm typically only good for an hour, but I have found a kind of a hack. If I pause it and then come back in 15 minutes or even as long as a half an hour and do something completely different, um, typically I can do another hour pretty easily. So let's do that. I'm going to just pause it, go over and do something completely different and unrelated to this. get off the computer even for a bit, and then come back and close out this and the quick quiz, at least if not the whole thing, but at the very least, don't stop until I've gotten beyond the quick quiz. So I'll be back.
All right, I'm back. So I'm going to see if I can either put in another complete hour up until 2:15 or so, two counts. I'm going to see if I can make this video go out to 2 hour mark, or finish up everything to quick quiz one, whichever comes first. So using tools in Llama Index, defining a clear set of tools is crucial to performance. As we discussed in Unit 1, using clear tool interfaces are easier for LLMs to use. Much like a software API interface for human engineers, they can get more out of the tool if it's easy to understand how it works. There are four main types of tools in Llama Index. There's the function tool, which converts any Python function into a tool that an agent can use. There's a search engine, a tool that lets agents use query engines. There's tool specs, a set of tools created by the community. And there's utility tools, special tools that help handle large amounts of data from other tools. Number one, function tool. Convert any Python function into a tool that an agent can use. It automatically figures out how the function works. And it does that, I think, through inference. I'm not even sure. Number two, query engine tool, a tool that lets agents use query engines. Since agents are built on query engines, they can also use other agents as tools. Number three, tool specs, sets of tools created by the community, which often include tools for specific services like Gmail. Number four, utility tools, special tools that help handle large amounts of data from other tools. We will go over each of them in more detail below. Creating a function tool. You can follow the code in this notebook that you run using Google Colab. So this can be quite comprehensive. Oh, it looks like a pretty small one this time. So let's install the modules and then log into Hugging Face. A function tool provides a simple way to wrap any Python function and make it available to an agent. You can either pass a synchronous or asynchronous function into the tool along with the optional name and description parameters. The name and description are particularly important as they help the agent understand when and how to use the tool effectively. Let's look at how to create a function tool below and then call it. When using an agent or LLM with function calling, the tool selected and the arguments written for that tool rely strongly on the tool name and description of the purpose and arguments of the tool. Learn more about function calling in the Function Calling Guide and Function Calling Learning Guide. All right, so let's see how this is going. It looks like it's done. So now I can log in. I'll feed the token in off camera. All right, I'm back. So the token is now fed in. So now we can create a basic function tool and call it. But anyway, the next part here says creating a query engine tool. The query engine we defined in the previous unit can be easily transformed into a tool using the query engine tool class. Let's see how to create a query engine tool from a query engine in the example below. Okay. So there we go. We see this works. So now let's reuse the query engine we defined in the previous unit on tools. So it uses a paid feature, unfortunately, and you have to, yeah. So yeah, this doesn't exist, but the one that does exist, you have to pay for. So unfortunately, we're not going to be able to use that. So next section is creating tool spaces. I need a quick break. I'll be right back. All right, I'm back. So let's keep going here. So, oops, I gotta close, open that up, if I may. There we go. So creating tool specs. Think of tool specs as collections of tools that work together harmoniously, like a well-organized professional toolkit. Just as a mechanics toolkit contains complementary tools that work together for vehicle repairs, a tool spec combines related tools for specific purposes. For example, an accounting agent's tool spec might elegantly integrate spreadsheet capabilities, email functionality, and calculation tools to handle financial tasks with precision and efficiency. Okay, so here's how you install it. And now we can load the tool spec and convert it into a set of tools. Okay. To get a more detailed view of the tools, we can take a look at the metadata of each tool. All right. Utility tools. Okay, so there we go. We look at and then, okay, so yeah, we can't run any of these codes because I don't have the, I mean, I think this playbook itself is a little bit out of date. I wish I could see when it was published, but I mean, it should have been published very recently. Yeah, it was published yeah. Well, I can't do the playbook because you have to pay the um, import statements in the playbook don't all work, and I have figured out how to make it work, but it just leads you to a service you have to pay for. So. All right, so utility tools. Sometimes directly querying an API can return an excessive amount of data, some of which may be irrelevant, overflow the context window of the LLM, or unnecessarily increase the number of tokens that you are using. Let's walk through our two main utility tools below. Number one, on-demand tool loader. This tool turns any existing LlamaIndex data loader base reader class into a tool that an agent can use. The tool can be called with all the parameters needed to trigger load data from the data loader, along with a natural language query string. During execution, we first load data from the data loader, index it, for instance, with a vector store, and then query it on demand. All three of these steps might happen in a single tool call. Number two, load and search tool spec. The load and search tool spec takes in any existing tool as input. As a tool spec, it implements to_tool_list, and when that function is called, two tools are returned, a loading tool and then a search tool. The load tool execution would call the underlying tool and index the output by default with a vector index. The search tool execution would take in a query string as input and call the underlying index. You can find tool specs and utility tools on the Llama Hub. Now that we understand the basics of agents and tools in LlamaIndex, let's see how we can use LlamaIndex to create configurable and manageable workflows. All right, but before we do that, we're going to take a small ungraded quiz. So this, I'm not going to worry about keeping these questions and answers private. It's just all out there. It's not graded. It's not part of the certificate. So I'll put these out there on my channel. So far we've discussed the key components and tools used in LlamaIndex. It's time to make a short quiz, since testing yourself is the best way to learn to avoid the illusion of competence, which we read about here. But you know what? This goes. Yeah. So if I log in, I actually was working my way through this. I don't think I finished everything. Let me see how far I got. But yeah, illusions of competence are very bad. So if we go to my profile, we can go to we can go to explore. Oh, just go to the main page. So it says welcome back. Exit that. Exit that. Let's go to accomplishments because maybe it'll. Oh, here we go. Yeah, so from the accomplishments page, we can see this. Okay, so if we click go to course, there. So I made it through module 2, but I haven't finished module 3 or module 4, which I should probably do. All right, anyway, moving on. So let's take the quiz. So this will help you find where you need to reinforce your knowledge. This is an optional quiz. It is not graded. So question 1, what is a query engine? Which of the following best describes a query engine component? Um, I'm going to say B. There we go. So the core purpose of a query engine component is to find and retrieve relevant information as part of the RAG process. All right, question 2. What is the purpose of function tools? Why are function tools important for an agent? Um, uh, so I'm going to go with B on that one as well, and I got it right. Function tools wrap Python functions to make them accessible to agents. All right, question 3. What are tool specs in Llama Index? What is the main purpose of tool specs? Um, I'm going to go with B on this one as well, and I got it right. So they allow the community to share and reuse tools. And what is required to create a tool? What information must be included when creating a tool? Let's see. So we're going to go with A. Oh, you know what? I got one wrong. I guess only the function is required. Yep, so that's the right answer. Okay, so I guess I didn't know that. See, I was thinking back to the small agents when you needed but you don't need that to create the tool. You need it to yeah. So I guess it's different here. I'm surprised that this is so yeah, I got this one wrong here. So congratulations on finishing the quiz. If you missed some elements, take time to read again the chapter to reinforce your knowledge. If you pass it, you're ready to dive deeper into building this component. So let's go back and review what is required to create a tool. So we're going to go to what components, maybe that was touched upon here. Um, I think it actually will be in the using tools. Yeah, so I think this is it. So you can pass either a synchronous or asynchronous function to the tool, along with the optional name and description parameters. So this gives you the answer here. Those are optional. The name and description are particularly important as they help the agent understand when and how to use the tool effectively, though. So I, it wasn't a bad wrong answer necessarily because although they are optional, you really do want to make sure that it has it. Otherwise, it won't be able to function properly. All right, you know what? I've got quite a bit of time to finish this. The next unit won't be released until Tuesday. So I think I'm going to end the video here. And then when I come back, we'll move on to using agents and Llama Index. So thanks for watching and see you in the next one.